Sophia? Okay. All right. Ms. Becker. So, all right. So we're gonna do 2 examples this morning, and then go from there. So, minimizing costs. Minimizing costs. So I need to start by trying to make some equations out of this to be able to minimize. So manufacturer needs to produce a cylindrical container with a capacity of 1,000 cm cubed. At the top bottom, containers are made of material that costs basically 5 cents per square centimeter. Okay, that should give you a key. What is that going to tell me? What's that clue? Anyone? What's that clue going to help me out with? It's going to be area. So I'm going to be doing an area problem. While the side of the container is made of material costing 3 cents per square centimeter, find the dimensions that will minimize the company's cost of producing the container. So, container itself, capacity. So the container's capacity, so what does that tell me I need to also have? Volume, very good. So, volume of a cylinder. So, volume would be pi r squared h. Yeah? Okay. Now, with the information given to me, I have to deal with the cost. So I'm trying to minimize the cost, right? Minimizing cost. So now, think of that. Minimizing cost. So I'm going to do what with that? Anyone? Is it too early? There's a clue in here. That was the clue that we started with. Huh? The surface area. We already did that. So we have the surface area, right? The surface area. What are we going to do with the surface area? We're minimizing that, right? If I'm minimizing the surface area, that's where I'm taking the derivative, right? Yeah. So my instructions right there, there's keys and hints for everything. So I'm going to minimize that. So I need to make a surface area equation for this. So in the cylinder, my area, if I have a top and a bottom, that means that the area of the top is going to be pi r squared, and since I have a top and a bottom, it's 2 pi r squared, right? Plus. So it's going to, so if I unfold this.
2 pi r times.
Yeah. So it's going to look like, I'll run out of the screen here. Anyway. So I have my top and my bottom, and I also have this piece right here, which is going to be the circumference of the circle. So 2 pi r times this right here. So that's my 2 pi r. And this is my height. So hopefully that will help you with this diagram. Now, there's something else I have to add. Since I am minimizing cost, I have to include cost in here. So the top portion costs me how much?
0.05.
Yeah, the top of the bottom is 0.05. So I'm going to include that here. So A is 2 pi r squared times 0.05 plus 2 pi r h times 0.03. Why I have one issue right now. I have to incorporate these two things together, right?
They would be better as fraction.
Huh?
They would be better as fraction.
Yeah, but I have to incorporate my two equations, my volume and my area, right?
Did you substitute the H?
Yeah,
Did
you
you, like,
Yeah,
solve for the
very
H?
good. That's what I'm gonna have to do. So I know that my volume is, was it 1,000
Yeah.
divided by,
Pi r squared.
yeah. Pi r squared is equal to my h. So I'm getting rid of my r. I'm sorry, I'm getting rid of my h and substituting with r's. And then I'm also going to clean up those 2's that I have out there and then help out with the decimal thing. So area is 2 times 0.5 is 0.1 pi r squared plus. And as I put that in, that's going to be 0.06 pi r, but my h is 1,000 over pi r squared. And I can do a little bit more cleaning up here. So I'm going to have pi here, so those go away. I can cancel out one of those r's, and the 0.06 times 1,000 is
600.
what? 3 zeros, right?
Yeah.
Move it over.
What?
1, 2, 3. So it's going to be
Oh,
60.
wait. Yeah, there. I was looking
Yeah.
the opposite way.
It's fine. So area no pi. No pi. 60.
Over r. Yeah.
Yes, but it'd be r to -1 because I'm trying to get this ready to actually do the derivatives now. So now that cleaned up real nice. That's a nice. And I'm getting to the bottom of the screen, so I'm gonna move it to another page. Pi r squared. Did I copy it right? Okay.
It's not 2.
It's not 2?
No.
Oh yeah, because I haven't done that yet.
Yeah.
Thank you.
It will be when we do the
Yeah. That's one problem with trying to carry everything over to another page. I have to be able to remember, more than 5 seconds. All right, take the derivative. So my a prime is equal to 0.2 pi r minus 60 over r squared. And it's set up for the next part, set it equal to,
R squared. Oh, 0, and then.
there you go, yeah, there we go. So min and max, so I need to set it equal to 0, so I'm gonna go 0 equals 0.2 pi r minus 60 over r squared. Multiply everything by so 0 equals, as I distribute that, I'm going to get 0.2 pi r cubed minus 60.
60 over 0.2 times.
And from here, start moving things over to solve, because that I don't have that variable, so that negative 60 goes over here. So 60 equals 0.2 pi r cubed, divide by 0.2 pi. What's that? 300? Yeah. So r is equal to the cube root of 300 over pi.
And then we just plug that in to find H.
Yep.
Does it matter if we plug it into the surface area or to the velocity? Or not the velocity,
Not really, but we're gonna plug them in anyway, because so right there, and then so going back to find my h, which I'm gonna plug in right here to make life easier. So that would be 1,000 over pi r squared. So this is gonna be ugly, so I'm gonna plug it in the calculator. It was it over 2 pi? No, pi r squared. There we go. So pi times r, which was the cube root of 300 over pi squared. Okay, and I don't know if you guys realize this, but this is actually important, especially if you're plugging in the calculator, like knowing how to use your calculator, but most people just go to their phones. But at this point in time, that's on you. Control, enter. So my h is going to be 15.236. And let's see, so that means So I'm gonna go control, yeah, control here. Let's see what this one with my actual R is gonna be. 3 over control divide. So this is my R, control enter. 4.571. All right, find the dimensions that will minimize the company's cost of producing the container. So, at a side note, what else could I do? So I have the dimensions. What else could I use? What else could they ask for?
Area, right there, the volume.
No, we already know the volume.
Yeah, the surface area.
We know we can plug that in. So yeah, we can get the surface area. And what else can we get? How about cost? Are we minimizing cost? Yeah, we're trying to minimize cost, right? So if I plug that in, and where would I plug it in though?
A.
Yep, for the area. So let's see. So 2 pi r cube root of squared 2 pi r squared plus it was 2 pi r times h, and my h was all of that. I don't think that one's right. Maybe I plugged it in wrong, but I have delete that part. Times, what did we say? Was it 15 point what?
For height,
Yeah.
8.236.
236. Same thing. Did I miss something when I plugged it in?
You forgot the cost part. Like the.
Oh, there we go. Yes, thank you. Thank you. Yeah. All right. So, and so this one's going to be times 0.03, and this other one is times 0.05.
Yeah.
Okay. Control enter. There we go. Alrighty. So thank you, Matt. So there we go. So it cost me almost $20 just to make this container. Now, 1,000 cm cubed is actually how much? Is it big? Yeah, 1 liter. 1 liter is 100 cm cubed. All right? So it should be 10 liters. So yeah, that's why it costs so much. Anyway. All right, now maximizing area. So this one right here is always one of those problems that you're going to see something similar to this. Do you not have these notes? Okay, so go in the box, and it's 4.7. Now, let's see. So rectangle is inscribed in a semicircle with a radius of 2. Find the dimensions of the rectangle that has the maximum area. So I know a couple things here. This is a right triangle, right? What's this value? What's the hypotenuse?
The radius,
Yes, what is it though?
R,
And that is?
6.
Yeah, it's 2 because the radius is 2, right? So that's one thing a lot of people actually miss out on, because the semicircle, so any point on the edge of the circle is going to have the same radius. All right, so I did that intentionally, so I'm trying to maximize x and y, right? I'm trying to get the maximum area. So if I'm getting the maximum area, I need to write an area formula, right? So my area formula here is area is equal to, what's the base going to be? 2x times, yep, very good. So that's the one I'm trying to maximize. But then I use that right here, and because I know that's 2, I could use this information to try and solve for.
That was your head.
Okay. Hey, never know. All right, so I'm going to set this up, and if this is a right triangle, what could I always use as the right triangle? Did I hear Pythagorean theorem? Yes, I did. Okay. So it's going to be 2 squared plus, no, not 2 squared.
X squared plus y squared.
Yeah,
plus
2 squared equals. There you go. And I want to get rid of one of these. And I'm going to use that to substitute. Because in that relationship, the x squared plus y squared could only equal 4 in this, no matter what. So that is a restriction on my y values. So it has to be within that. So let's see. So I'm going to say that y is equal to 2 squared is 4. Minus x squared. So y equals plus or minus the square root of 4 minus x squared. Now, include the plus and minus always. Do we get to ignore that plus and minus though?
Yes.
Yes, we do. Because the plus and minus would be both halves of this circle. The plus and minus. So the minus would be the lower portion of the circle. We're dealing with the top part, right? Okay. So, there we go. So now I have a value for y. So let's plug that in. So my...
Simplify it to, or not, with the square root.
A little bit louder. I wasn't really sure what you said.
Well, could you just simplify that, the square root, for like 2 minus x?
Oh!
No?
Math foul.
Yeah.
That minus sign messes that up. If it was a 4 times x squared, I could. But that minus sign in between says no.
Okay.
So, setting it up because I know I'm going to have to do some optimization here, so I'm going to have to take a derivative. So doing this, so let's go ahead and take my derivative from here. What rule am I using? Product. So it's going to be A prime is equal to 2 times 4 minus x squared to the 1/2 plus 2x times 1/2 4 minus x squared to the negative 1/2 times the derivative of the inside, which is going to give me a negative 2x. You okay? So I'm going to have to do a lot of cleaning up here, though. But it's going to make my life a whole lot easier by cleaning this up. So I'm going to say A prime is equal to 2 quantity 4 minus x squared 1/2. This 2 and this 2 go away. And then I have an x times x. So this becomes a minus 2x squared over 4 minus x squared to the 1/2. Set it equal to 0, but before I do that, I'm going to transfer it to another page so I have more room. Hopefully I copied that down correctly. Yeah, I'll just wait for everyone to get to this point. So yeah, set it equals 0. And, do they both have a factor of 2? Yeah. Can I factor that out? That is going to make my life a little bit easier here in a minute. You'll see. Does 2 equal 0? Or divide both sides by 2, that would work? Okay, if I divide both sides by 2, what happens to this 2 right here? It goes away. It just cleans up my distribution here. So right now, since this is over 1, I could look at this and be like, hey, what can I do here now? I have a fraction over there, so I'm going to multiply both sides by the common denominator. My common denominator here is going to be
4 minus x squared to
very good, yeah, 4 minus x squared to the 1/2. And by doing that, distributing it, so that's going to give me still 0 equals, when I distribute it over here, I'm going to get 4 minus x squared minus x squared. So let's see, 4 minus 2x squared equals 0. Negative 4 equals negative 2x squared. 2 equals x squared. X equals plus and minus the square root of 2. So from my diagram, that means that this point right here is positive rad 2. This one right here is negative rad 2. Find the dimensions that has the maximum area. Okay, so now I have that. I can plug it in. Got to try and find y. So I'm going to use that y that I have down there with the plus and minus. So I have that y so y equals, in this case I'm going to ignore the negative, 4 minus x, which is rad 2 squared. So y equals, what's that going to give me?
Rad 2.
Yeah, so it's going to give me rad 2. So this is going to give me 2. 4 minus 2 is 2, so rad 2. And if I wanted to find the maximum area would be my x. So 2 times my x, which is rad 2, times my y, which is rad 2. So my maximum area there is going to be 4 units squared. Yes, no, maybe? Not too bad, right? So we still got 15 minutes of class. And how many problems did we have on that part D? I think there was only like 4 problems. And then the AP questions.